Proportions. I can apply the relationship between ratios and equivalent fractions to solve various problems, and I can use reasoning about multiplication and division to solve ratio and rate problems by setting up something called proportions. So first, let's get a ratio. A ratio is a relationship between two things. I'm going to take off the word different because when we get to rate, we'll be looking at that too. So a relationship between two things. A proportion, two equal ratios. How do you know? Well, we start by looking at how did we go from here to here? Well, 2 times 4 was 8, and 3 times 4 is 12. So because these are the same, which we call the factor of change or proportionality, they were not proportioning the same thing, we get the same answer. They're equivalent. Remember, there's other ways to check too if they're equivalent. We can check by crossing. 2 times 4 or 2 times 12 is 24, and 8 times 3 is 24. That's one way to check. Another way to check would be to divide. 2 divided by 3 is 0.6 repeating. And that's the same as 8 divided by 12 is 0.6 repeating. So because all those things equal, we know that it is the proportions are equal. We're going to start with looking at factor of change. How much a ratio changes by multiplying or dividing. So in this case, it's this. It changed by 4, and because we're multiplying, it went up by 4. If you are dividing, it would go down by 4. So let's use this idea of factor of change to solve some proportions. So write 5, 6 equals x over 18. How did I go from 6 to 18? I times by 3. I got 3 times bigger. So if I times 5 by 3, this would be 15. So 5, 6 is equivalent to 15 18s. Now I can check that. Let's cross it. 5 times 18 is 90 if I cross these two. And 15 times 6, if I cross those two, is 90, so I know I'm correct. So we are using the reasoning between multiplication and division. That's why we have to use that factor of change. Okay, let's look at one more. How did I go from 30 to 6? Well, in this case, I divided by 5. Oops, but I have nothing. So I could think of divide by 5. What divided by 5 is 5? It's one way to think about it. The other way is just start on the side that has both of them. So if I start on the side that has both, I can actually go in this direction. 6 times what is 30? 6 times 5 is 30, and 5 times 5 is 25. Okay, so let's take a look at this. Start on the side that has both. So again, the factor of change was 5, and my answer was 25. So we start on the side that has both, times 7. So 8 times 7 is 56. Factor of change was 7. My answer is 56. I can check by crossing them. All right, let's do another one. How did I go? Well, I can't go this way because it's got both. So start on the side that has both. How did I go from 12 to 3? I divided by 4. 16 divided by 4 is 4. Okay, so my factor of change is 4. My answer is 4. I can check because 12 times 4 is 48. 16 times 3 is 48, so I know it's correct. What happens, though, if it doesn't go in nicely? That one went nicely. What happens if it doesn't? Here's what I want you to write down. If it doesn't go in nicely, simplify first. So, for instance, let's write this one. I start on the side that has both. 55 does not go nice into 12. I call them plain nice. So I have to think about this for a second. How did I go from 55 to 20? I can't. So let's see if we can simplify first. Well, 11 goes into both 55 and 11. And we simplify first. That's why I want you to write this. 11 goes in there 5 times, and 11 goes in there once. So now how did I go from 5 to 20? I times by 4, times by 4, and this would be 4. The factor of change in this case, I went down by 5. I made it 5 times smaller to then make it 4 times bigger. That's how I would describe the factor of change. Stop the video and try this one. Okay, so I take a look. I start on the side that has both. 13 does not go to 4. So I need to simplify. Well, 13 goes into 13 once. 13 goes into 39 3 times. Now I can look and say, yes, 1 to 4 would be times 4, and 3 times 4 is 12. I can go back to the original problem because I can see 1 times 12 is 12 and 4 times 3 is 12 to know, but I could also go back to the original problem and I could check it, remember, by crossing and say 12 times 13. Well, 12 times 13 is 156, and 4 times 39 is also 156. So it's just a way to check. To describe the factor of change, hopefully you would have said you went down by 13 to go up by 4. So you made it 13 times smaller to make it 4 times bigger.